This is an important concept that a lot of students struggle with, and there's many aspects and there's several steps to this problem. So let's just dive right in. We have a complex number with a real part and an imaginary part. They're asking for the polar form, and they want us to make sure that whatever angle we find, it's in terms of radians, and it's between 0 and 2 pi. Anytime we have an angle, it can repeat itself every 360 degrees. So this just kind of helps make sure that we're in between, or it repeats itself every 2 pi in this case, so that we're in between that. All right, so the first thing I want to do is I just want to get out a few formulas that we need to kind of help. First, the formula for polar form, and the polar form formula is Z would change into a magnitude R times cosine of whatever the angle is plus the imaginary part times sine of whatever that angle is. Okay? And so right away I see, okay, I need R also. The formula for R is equal to the square root a squared plus b squared. Remember, R is the magnitude or the distance of that vector, which can be found using like the Pythagorean theorem. In this case, we'll just jump right into the formula. Hopefully you're not still using the Pythagorean theorem to get there this way, but if you do, that's fine. So we'll start plugging our pieces in. This here is A. This here is B. And of course, that's our I. So, plugging it in, let's take care of R first. It's right there, ready for us. So now we have, plugging the A and B in, R is equal to the square root of A squared is 3 root 3 quantity squared, plus our B is -9 quantity squared. We'll go ahead and simplify this one. The exponent applies to each part here. So it's 3 squared and radical 3 squared. This turns into, we still have our square root sign. 3 squared is 9. And the radical 3 times radical 3 is radical 9, or just 3. -9 times -9 is 81. That's equal to 27 plus 81, which is equal to the square root of 108. It looks like 108 can reduce. Let's see, that would be 2 times 54 and 2 times 27. And 27 breaks down into 3 times 9. And 9 breaks down into 3 times 3. So all of this is still under the radical. I have, I'll circle what we're focused on. We're focused on those. So from the prime factorization, this turns into the square root of 2 times 2 times 3 times 3 times 3. I like to pull out pairs. Pair of 2s, pair of 3s, comes out as one number. And now we have, this is equal to 2 times 3, and there's still that last 3 in there. So R is equal to 6 radical 3. Okay, well we got one part of it. We got the R. So I'll go ahead and R is equal to 6 radical 3. Now I need to find theta. We need our theta. So they gave us kind of in a rectangular form style. So I'll go ahead and draw a graph so I can see what the angle looks like. Real important, we have the graph that lets us know what quadrant we're in. That matters so we can make sure our signs are correct. And we have the real axis, the imaginary axis. 3 root 3. What is 3 root 3? So I type in radical 3 times 3 is about 5.19. 1, 2, 3, 4, 5, 6. 5.19 would be right there. So that's 3 root 3, which I'll just write it, which is about 5.19. I'm not going to worry about rounding it properly, just make sure we know where we're at. And then we have a negative 9 on the imaginary. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9 on the imaginary. So there we are. And that would be our Z1 using the rectangular form. Well, this is the vector that's kind of created, and we're going to find that polar form. So we always start at the 0, and if we go around, this is the angle that we're looking for. So that's our theta that we're looking for. When we deal with the triangles this way, we look at it in terms of compared to the real axis, or we always go up or down. So in this case, we can't use theta because it's too big to do our analysis on it. So we're looking at what that angle is right there to do the work, and then we just got to make sure we compare it to what we really want. So this time I'll go ahead, and sometimes they like using phi. I'll go ahead and call that new angle phi. And I just want to make sure I don't use that at the end. All right, so we'll start labeling some things. On this side right here, that's 9 units. On this side right here, that's 3 root 3 units. Okay, and to find phi, we use some trigonometry. With this angle, that would be the opposite side. This would be the adjacent side. And what trig function has opposite and adjacent in it? Tangent does. So tangent of our phi is equal to opposite over adjacent. You can use SOHCAHTOA to kind of help you keep track of that if need be. Plugging in our numbers. The opposite side is 9. The adjacent side is 3 root 3. Now, Sanders, I usually don't, and usually in math we don't like having radicals in the bottom here. But I think we can kind of get away with it this time since we're going to be using the calculator to kind of finish this off. So we have tangent of phi is equal to 9 over 3 root 3. Solving for phi, I do arctan of both sides. So if I do arctan of this side, the tangent goes away, and we're left with phi is equal to tan inverse or arctan of 9 over 3 root 3. Okay, so we're almost there. We want this in terms of radians, having pi float around. This looks like a big mess, so I'm going to go ahead and the trick I'm going to use, this calculator can spit out radians. So if your calculator doesn't spit out radians with pi's in it, then my suggestion would be to calculate this in terms of degrees and then use your converter of pi over 180 as a multiplier of whatever that is in degrees, and then out will come out your solution with pi in it. Okay? I'm going to go ahead and I'm in degrees now, and let's go ahead and look at that anyway. So I'll do degrees first, And then we'll change it into radians. If you have a calculator, you weren't able to do it with the radians. So let's see, so I would calculate all of this first, and then I would take the arctan of that. So I do 3 root 3 equals, so I calculated this first. Then I do 9 divided by that answer, which is just root 3. Things cancel pretty nice. And then I'm doing arctan of that. Arctan of root 3 is equal to 60 degrees. Okay? This is a special triangle. So far in this class, we've not hit special triangle angles, so I'm not going to worry about it just yet. We have plenty of time to do that. So this 60 degrees, to find out what that is in radians, we would multiply it by pi over 180 degrees. The 60 goes into 180 3 times, so all of this turns into phi is equal to pi over 3. Okay? So we're almost there. Be careful. When I did this, I went ahead and I plugged that in to here. One of the good things about using different symbols is I can see, oh, these don't match. So what was the relationship between phi and theta? Well, all the way around a circle is 360 degrees, or 2 pi. So I'll look at it as the 2 pi is right here. So this 0 degrees is also, if I go around, it's also equal to 2 pi as if I go around. So the idea here is this 2 pi, I'm taking away the phi from that. So I'll go ahead and I'll take this, because basically what I'm doing is I'm just going this direction right here. That's what I found. So I need to take that away from the whole 360, or the 2 pi. And if I take this away from the 2 pi, then I'm left with the angle that I want. So I have my theta is going to be equal to the 2 pi minus the pi over 3. And theta is equal to, 2 pi is really 6 pi over 3. 3 goes into 6 2 times. Minus the pi over 3. Now that's better. I got my theta is equal to 5 pi over 3. Okay, we're almost done. And then they want it in the form of this form right here. So I'm just going to plug it in for each part. Since I've ran out of room, I'm just going to do it. I'll replace the magnitude with the final answer. Okay? So here's my final answer. Plugging things in. Z1 is equal to R, we found was 6 radical 3. Parenthesis, cosine comes first. The theta we found is 5 pi over 3 plus I sine 5 pi over 3. And everything looks good there.